So now we're going to get into a little bit of statistical analysis and how it applies to geospatial data. A histogram is a graph of all of the individual values of data organized from smallest to largest and displaying the numbers of times each value occurs. Histograms make it easier to examine data classification. The x-axis shows data values and the y-axis the number of times that value occurs in the data set. Data classification is used to simplify and understand numeric data. Through classification, it is possible to identify patterns and trends or alter data by creating a subset of specific classes. One would do so by creating a series of class intervals, which are a range of values that do not overlap. The value that defines the boundary between each class interval is called a class break. You can think about it as a series of buckets that the data gets sorted into. We will go over equal interval, quantiles, natural breaks, and mean standard deviation in this lecture. It's also, all of those are explained in much more detail in the text as well. Same with the manual classification, but basically within the manual classification, you set the classes yourself in the histogram rather than having it calculated by the other classification methods. The equal interval classification method divides the range of data by values by the number of classes chosen. By doing so, it creates class intervals with equal ranges of values. In this graph here, the range of population values is from 0 to 8,188, and there are 4 classification intervals. The equal interval methods divide 8,188 by 4 to get 4 equal classification intervals, each with a range of 2,047. And this histogram is for the data that is displayed in this map here, and both of these graphics are in the text as well. In quantile classification, each class contains an equal number of features. A quantile classification is well suited to linearly distributed data. Quantile assigns the same number of data values to each class. There are no empty classes or classes with too few or too many values. Because features are grouped in equal numbers in each class using quantile classification, the resulting map can often be misleading. Similar features can be placed in adjacent classes, or features with widely different values can be put in the same class. You can minimize this distortion by increasing the number of classes. With natural breaks classification, sometimes referred to as Jenks classification, classes are based on natural groupings inherent in the data. Class breaks are identified that best group similar values and that maximize the differences between classes. The features are divided into classes whose boundaries are set where there are relatively big differences in the data values. Natural breaks are data-specific classifications and not useful for comparing multiple maps built from different underlying information. The standard deviation or mean standard deviation classification method shows you how much a feature's attribute value varies from the mean. The mean and standard deviation are calculated automatically. Class breaks are created with equal value ranges that are a proportion of the standard deviation, usually at intervals of 1, 1/2, 1/3, or 1/4 standard deviations using mean values and the standard deviations from the mean. Just a little caution, mean standard deviation works best with normally distributed values or bell curves.